Hello everyone, and thank you for joining us for today's webinar, Introducing RapidMiner 7.4. I'm Haley Matissa with RapidMiner, and I'll be your moderator for today's session. We're joined today by Lars Boyerly, Chief Product Officer, and Jesus Puente, our Product Manager here at RapidMiner. We'll get started in just a few minutes, but first, a few housekeeping items for those on the line. Today's webinar is being recorded, and you'll receive a link to the on-demand version via email within 1 to 2 business days. You're free to share that link with colleagues who are not able to attend today's live session. Second, if you have any trouble with audio or video today, your best bet is to try logging out and logging back in, which should resolve the issue in most cases. Finally, we'll have a question and answer session at the end of today's presentation. Please feel free to ask questions at any time via the questions panel on the right-hand side of your screen. We'll leave time at the end to get to everyone's questions. I'll now go ahead and pass it over to Lars.
Hi, thanks Haley, and welcome everybody then to the introduction to RapidMiner version 7.4. So Jesus and I will walk through and show you all the new good stuff in here. And really the goal of the release was to speed up the way in which you guys can do your data science. There are a number of additional features here that make it faster to do things. We'll take advantage now with this release, take advantage of all the computational resources on your computer, whether it's for data prep, modeling, validation, and some of the optimization things you can do. So the bottom line is really that by doing it and speeding things up this way, we can do more things faster. We can maybe iterate more turns. We can run broader optimization schemes and things like that. So we can do a lot more within the same time with these features then that speed things up. And if we think about the process here of doing data science, going from the prototyping stages where you do some data prep and test out various models and play around and figure out what will and will not work. Well, here everybody does that, so 100% of the time you're really in doing this type of work. Then as you find something interesting there and you want to substantiate it or validate it further, in some of the cases then we estimate like 30% of what you do might move on to this stage. You go in deeper, work harder on it, run a lot more data to test things, and then the deployment, of course, happens with even fewer, or some of those things that you came up with through the validation might actually be really beneficial to the business, and you might integrate that further into other systems and into those business processes. And the way we look at the product and some of the capabilities we have, we have really focused 7.4 then on this early phase here. How can we do prototyping faster? How can we gain more productivity here? So, and also the value of productivity itself is obviously more applicable in this prototyping phase. If you can save a few hours doing things, that could be worth quite a bit of money. As we move into the deployment or operationalization, yeah, you get more value obviously through working with more data. Processing speed also has some effect there as well. But for this release, we've really focused on the usability, performance, and capabilities for you working in the studio product on your prototyping work. And what we've done then is we've added some more operators that can now execute in parallel and use multiple cores. So a number of loop operators have been added to the list. We've also introduced a completely new feature, which is a background process execution. So this feature lets you execute a model, or a process in the background while you continue to use the rest of RapidMiner Studio or the GUI. So you can be working on one process while you have others running in the background. Jesus will demonstrate this to you. You'll see how that works. Very handy feature, saves you a lot of time. We've also improved or extended our Spark RapidMiner Spark RM concept. So now you can actually run any operator that's within the RapidMiner product and even extensions and across a whole Hadoop cluster. In the previous releases, you could do this in just one of the nodes, but now you can fully distribute it. And there are a bunch of enhancements and other fixes in there, and we'll talk through those as well, or some of them. So yeah, where do we then gain this speed and productivity? So in the data preparation phases, you'll be able to parallelize work now. You can, for example, loop through a bunch of files in parallel, which could really speed up use cases like tokenizing a large number of text files, for example. We've also then in the algorithms area, there have been already previous operators or models or algorithms for modeling that have been parallelized, and we'll reiterate those, you know which ones those are. And then the validation, we can run a validation in parallel as well. That was released in the previous release. And also then in the optimization area, you could then set up and work through that within validation, for example, or through looping, and do that much faster. So what's great now with the 7.4 release is that we cover all the main steps here of the model development process, and you can gain performance improvements and save time in all of them. So to look back a bit then, in RapidMiner version 7.2 and 7.3, we introduced a number of things that can use multiple logical processors or run in parallel, right? So a number of algorithms. The bottom two, the decision tree here and some random forest, we did a little bit earlier, but we also re-implemented them in the 7.2 here to be on our new parallel framework. In 7.3 then we put more of that in place and also added the cross-validation, which can then run against or across multiple processors. In 7.4, yeah, we've added then the loop operators. Here are the 4 most commonly used and cover most cases. So those have been parallelized. And you'll see when we do the demo, it'll speed up things quite a bit. And what's nice then with these are that they really can help you address some of the data prep things you do, you know. So they are very applicable to file reading, generate attributes, and so on. So should be quite useful. Also, I mentioned this background process execution, right? So this is a very neat feature. So this allows you now to execute multiple processes in parallel and utilize your cores or your CPU. So as the screen indicates here, if you look where that orange arrow is, there's a list of processes that are actually running or have completed. And while that's happening, I can still work on the process in my design view. And this really lets me kick things off and run them while I can continue to work. I don't have to sit and wait for RapidMiner to be done and freeze up the screen, but I can move on and continue to do other work there. And yeah, this could be a huge productivity gain, and it's intended really for power users and consultants and so on that, you know, need to run these bigger kind of things. And so this feature then is available in our RapidMiner Studio Large license. So that's our top of the line offering. So with that then, we'll jump right into the demonstrations, and then Jesus can show you a few of these things. Let me quickly then change over to his computer here, and he can start to share. Good. We can see your screen here, Jesus. Can't hear you yet.
Yeah, sorry, I was mute. So yes, thanks, Lars, for that. So yes, now I would like to give you a demonstration of what Lars has been introducing. So as he said, we have a bunch of new features which are very interesting in terms of performance and productivity, right? So just let me also take the opportunity. One of the other features that we have added is a few new templates, like new different test use cases that you can click and start. So take a look, and they can give you like a first starting point to develop your own processes, some related to sentiment analysis, series, and some others. So it's not only performance related. There are also a few more features. We'll talk about them later. But going back to the productivity story and the performance story. So going back to some earlier releases, we had already started using some parallelized algorithms, like decision tree or the random forest. This was earlier last year, and then we added a few more in the latest release in the last quarter of 2017, like related to H2O operators, like gradient boosted trees, deep learning, and so on. This is very interesting because really this speeds the execution of the algorithms really a lot. But this is a benefit only for those users who need, in particular, these algorithms like decision tree or deep learning or logistic regression. If there is any other algorithm that you're using, then it's not that good. So that's why we started adding what we call meta operators. So operators which are used together with other algorithms, with other types of operators, like the cross-validation. So looking at the graph that Lars showed at the beginning with the prototyping phase, that everyone is doing that phase, cross-validation is one of those operators that everyone needs to use in order to estimate how good or how bad the model that one has come up to is. So in this case, for example, I'm using a cross-validation. If I double-click, I get inside, and I'm trying to get an idea of how good this linear regression in my case is. So now we have added an option. It's enable parallel execution. So I can run, sorry. So let me disable this part. I just wanted to show it. So if I just run it like that, it will take some time because all the faults of the validation, so this is basically validated by splitting the data in test and validation part. So this is happening like 20 times, one after the other, so it's taking some time. It will take about 20 seconds more or less, right? Because it's doing it in a serial manner, right? When we finish in a few seconds, we'll see the results, which is basically the performance and the model and so on, and it's taking 32 seconds in this case. If I now enable the parallel execution, what happens is these 20 tasks are being run, and all the cores in this is an 8-core laptop that I have, and it's going, as you can see, it's much faster. It's taking 8 seconds, so 4 times faster, right? It depends a bit on the data, on the actual algorithm, and so on, how much faster you can get, but the difference is really big. This is about the cross-validation that we had actually in 7.3. Now we have added also some loops for 7.4. Also, these loops are good because this helps everyone that in general, not really those using a particular algorithm. So we see a lot of loop usage in ETL, in the data preparation, but it can also help in the model in itself if you want to test different models or different configurations at the same time. So we have added the ones which we see are most used by our user, like loop attributes, loop files. For example, if you want to simultaneously open and ingest some different files, the generic loop and loop values. So I'll do the example with the loop values. So similar to what we saw before, I can run it in a serial manner. In this case, by loop values is if you have, for example, in this data, the marital status, it can be married or divorced or single and so on. So there are like 4 or 5 different values. So this is the iteration. So there are like 4 or 5 different tasks that in this case are being run in a serial manner, right? And again, it will take like 20 to 30 seconds, right? Something like that. It finished. We get the result, 30 seconds again. Again, if I click on Enable Parallel Execution, then it will go much faster. Now I'm making use of all my 8 CPUs. As you can see, it's much faster. 5 seconds in this case. It's 6 times faster than before. So you can see the difference is big. Even in this, I repeat, it's an 8-core CPUs. It's normal to see these days 16 and even more cores in a single box. So the difference can be really huge. We have also taken the opportunity to add some more functionality to the loops. I'll use a different example in this case, and it's these reuse results. So if you run a loop, and here what I'm doing is generate some attributes. So basically I'm changing the table, right? The table I'm starting with. I will be adding a couple of new columns of new attributes. And the result is, because this one is repeating this 5 times, there are 5 iterations, is that I get 5 different results, so 5 different tables, and each one has 1 added column, 2 in fact. The iteration, so loop number 3 is adding just a 3, just a very simple example. Loop number 2 is adding a 2. So I get 5 different results. But another kind of loop would be, what if what I want to do is repeatedly change the same table, right? So in this case I can reuse results, and then what is happening is that the same table, so I get as a result a single table, is changed over and over again. So I add 1 column, then a second column, then a third, and so on and so forth, right? This is another kind of functionality that we have added to these loop operators. As you can see, if I click on reuse results, the parallel execution disappears, because in fact what we are doing is that the output of iteration number 2 is going as an input of iteration number 3 and so on, so it can't be done in parallel. This is about loops and regarding performance. And there is another performance-related feature. It's more on personal performance, so productivity, which is what we call the background execution. So by now, as you have seen, if I'm running a process, I have to wait until it finishes before I can continue working, right? So this is when we use the play button, or if we can run it on a server. Now we have added another option, run process in background, and what happens is then I can open this new panel and I can run it there. So let me choose another one that takes a bit more time. Let me do it not in parallel. So if I run the process in the background, it's still here. I can still go here, move, reconfigure, do whatever I need. And if you can see here, I can actually see that what it is doing, if it is running, where it is going, and I can continue to maybe go take another model, another process. process, I can drag and drop directly, and so on and so forth. So I can drag in principle as many as I want. I have information about what the results are, so I can see here if this is the result. If this one has finished, I can click on the results, and then I can see actually the results. If they are running, I can see what they are doing. And by the way, because this is adding a lot of load to the machine itself, then well, this one failed because it was disconnected. But I can see here, for example, performance or whatever. I can see which ones failed. If it failed, I can see the actual error and so on. And as I was saying, because this is adding a lot of load, I can also control by a new parameter. I can limit the number of parallel processes. So this one by default is 0, which it means all cores except one, because one is reserved for Studio itself, and just to not to lose this kind of agile. I mean, the laptop can continue working, and so that's why we chose number of cores -1. But I can reduce it more, like 2, like what I had, and then if that happens, I can run this here, and if there are more than 2, then it gets scheduled, but it won't start until the others finished, like in this case, right? So this is basically what we have in terms of productivity. As you can see, this is very important especially in long-running processes. So if you have a process that takes 15 minutes, an hour, 2 hours, then you can continue, try again, change configuration, change the process, take a look at the different process, and just as this is running, and once it finishes, then you can see the results, right? You can also, once it's there, you can double-click and actually see the process that you had, and so on, right? So that's basically about that. Going back to the slides, to the presentation, I want to talk a bit more about these kind of performance improvements. So we have studied a bit more. So we have created some test configurations using different data, different algorithms, using also different configurations, so from 1 to 32 logical processors, just to have some numbers to show, just to see how much this could actually help. And these are some of the results. We can get up to 10%, 10 times better performance and in improvement compared to a single logical processor. So this is obviously related to the licensing level, which allows a number of cores to be used. So we can get from, let's say in some cases this was a gradient boosted trees, for example, from 7 minutes to 30 seconds. Some long running processes from 25 hours to just a bit more than 3 hours, and it's a steady improvement. So it is clearly an advantage for users to use this kind of operators and this parallelization, right? This is just part of the results. We have created this this white paper. In fact, Ingo Biersma, our founder, wrote it, and you can download it from our website. So I really invite you to do this and read it through. There we describe exactly the cases, the processes that we tried, and so on. So it's an interesting read. In terms of how this is packaged, well, we the licenses. So we have 3 licenses that you can use with just one logical processor. The whole functionality is there, meaning that you have basically all operators and so on. We give a lot of, and we want to give a lot of value to our community, to the people who just download the tool and use it. Then for people more focused on enterprise needs, the better the licensing, the better the performance you get in this case, both for the parallel execution and also the background processing execution, which is included in the large license, right? Going a bit further, this was mainly for Studio, and the next thing that I want to show is about what we have changed in Hadoop, or our connection to Hadoop. And the main thing is this Spark RM operator. So Spark RM is a new operator that allows you to introduce operators and so processes in it, not designed for Spark or for Hadoop, just the standard regular RapidMiner operators, and push them down to Hadoop nodes in parallel, right? We already had some functionality to push down this kind of operators in a single node. Now it's made in parallel, so it really now makes sense because, well, everyone expects that everything in Hadoop is parallel. Data is distributed, so we make use of that distribution. So it's really opening a lot of new use cases. The change is that this is the way Hadoop in general works, and by the way, it still works like that, and it makes sense to use the existing operators. Is each box's operator is making use of different Hadoop services. Some, mostly about ETL or data ingestion, use Hive or Impala. Some use Mahout. A lot use Spark machine library, MLlib operators. And then what we are doing now is adding like a new kind of box where we, in this is the Spark RM operator, we can inside it add just any kind of sub-process. Here in this example I have added cross-validation, so it's not just algorithms, it's just anything. And then what happens is that this is encapsulated, sent to Hadoop, and it will be executed on the partitioned data, right? That's the way. So the way it works technically is that we actually partition the data. We can use the existing partition on Hadoop, on HDFS, or we can actually shuffle the data or implement some kind of specific partitioning depending on attribute values or other types. Then the code is, the RapidMiner code is pushed to the nodes. It's run on the data, and then this goes back and it can be optionally merged, both the data, and if the output is a model, we can combine it into a voting model, right? So that's the way it works. This is working, as I said, with all the RapidMiner operators, including extensions. So one of the use cases that we see as very interesting would be text mining, but also series forecasting, process mining, which is one of the extensions that we have. I mean, there are many of those, right? Let me, well, just talking about the packaging is basically Spark RM is for the enterprise licensing. And before we go to some new features, let me also do a quick demo on that. So basically, if I start with something new, just to show you why we think this is something very interesting for many of our users. Let me choose a connection. I have a virtual machine with a Hadoop. In this case, it's a Cloudera environment, but as you know, we also support other distributions. And let's say I create my nest, so everything that I put here or write here, design here, will be run in this Hadoop environment, right? So typically someone could take some data, right? Let's say from my Hive tables. Let's say I have this table. Maybe I'm also interested in another table, right? And maybe I would use some kind of ETL process. So let's say I want to join those two, right? Like that. Let me see, so I can use this attribute as an ID. I can even set role, Hadoop, set role, right? So this would be someone trying to credit worthy. It's a label. This is what I want to predict in this case. By the way, this is just some financial data that I'm going to play with. I don't think it's even interesting to show. But the idea is that now someone has finished, a developer or a user has finished with the ETL part, and I want to, well, try some modeling, right? So I would go to my Hadoop modeling part, and I get, well, logistic regression, decision tree. Basically, these are the Spark MLlib options, right? But what if I want to do something else? What if I'm doing, as I said, text analytics or process analytics, or if I want to use something more sophisticated, like the new deep learning operators, right? I would like to be able to do something like this. Well, that's exactly what we can do now with the Spark RM operator. So the way I would do it is, let's add it here. Let me just do the connection before even we do it. I'll take this out. And if I get inside the operator, I can put my deep learning here, and it will be encapsulated and run into the Hadoop environment. So let me also, just to show that we can also do even more and apply the model inside if needed. Let's see, do something like this. Of course I would, sorry, in fact I need this apply model, not the Hadoop one. Right, I could validate using my cross-validation, something like that. So let's say I'm done with that. I have this operators. So as you can see, in 5 minutes I have finished my my process. I can run it because I have this thing, so I can run it in the background. So I have this, even if I haven't even saved it, it's already there, and it's already running in my Hadoop environment. So if I go to here, this is my Hadoop environment, and okay, it's not started yet, but it will, in a couple of minutes, it will be there. So I can see, for example, it's already in the Spark RM phase, right? So this is the use case. Whatever you need to do beyond RapidMiner, beyond Spark MLlib, beyond what we already have in Hadoop, you can do. We can have different partitioning. Linear means we're using the existing Hadoop partition, but we can reshuffle data to add something related to attributes, to randomize. We can merge the output, in this case, to get just one single table. We can also combine the models if needed. This is all we can actually do, right? Let me check if it's already there. So it is already running. I can see the Spark RM. First task is a map reduce. Second will be a Spark one, and so on, right? This is about it. It takes about 2-3 minutes to finish. So let me go back to the presentation and introduce a few more things before this one finishes, right? So let me just go back to the demonstration. We were here. Okay, so there are some additional features. One is the SAS reader. We already had one SAS reader before, but it could only cover versions, older versions of SAS. SAS changed the way they write these files, so now we have adapted. What we can do is not reading the models, we are reading just the data that you can write using SAS. So this is interesting for people who have SAS in their company, which is usually quite a lot of people. I have already talked about or shown a little bit of these new templates, some for outlier detection, geographic distances, fraud detection, web analytics, sentiment analysis, and series forecasting. These two, well, you would need the extensions for them to be shown there, but I think they are quite valuable, and we have had some good feedback on this. Another feature is also regarding Hadoop, and in this case a technical configuration. Hadoop impersonation is a security setting in Hadoop where you can create a super user in the Hadoop environment so that it can impersonate or run as different users. This would be like a kind of simple architecture. In this case, you would need the RapidMiner server, which acts as a kind of proxy, right? So whenever a user in RapidMiner Studio logs in to the server as RapidMiner user 1, 2, or 3, whatever, then the connection is done as super user, and then this one impersonates the initial user, right? This simplifies a lot the configuration, and it is a more secure environment. This doesn't mean that we don't support the original configuration of each user having his own or her own configuration. That's also supported now. It's just added. Other different enhancements, like, well, now you can sort by name and also the time, the last modified time of your repository, which is quite handy. We have published the API for what we call the concurrency API that we have for developing parallel execution operators. We have also added Spark 2.1 support. So this happens a lot with Hadoop. We have to, it's a very fast-moving environment, so we have to basically run a little bit to support the latest versions. We have done this time with Hadoop. There is a lot more. We have improved performance in different operators, more logging capabilities in Hadoop, annotations inside the Hadoop nest. If you want to take a look, it's in the release notes in our documentation, both for Studio, Hadoop, and the server. There is a detailed account on that. And that's basically all I wanted to show you. Just to show this one has finished, so I get the single table like that. I want to stop here because I know there are some questions, and there are only a few minutes left. So just just to show this one, the result is that we seamlessly joined the table into a single table, and in this case there is also, as a result, the collection of the different deep learning operators. So I'm getting basically the same thing that I would have got by running this in memory, right? This is the idea.
Great, thanks, Jesus. Yeah, we have a few minutes left then for questions. We can, if you type them into the questions dialog there in your GoToWebinar panel, if you go down towards the bottom of it, there is a questions label, and you can open that up and then type in a question and we can answer them. We've gotten a few questions here already, and I took the time here while Jesus demonstrated. I went through a few of the slides to reply. Hopefully you can see that. And then if you have any other questions related to the presentation here, feel free to ask. We'll take them.
Thanks, Lars. I just wanted to chime in quickly. So as a reminder to those that are on the line, we'll be sending the recording of today's presentation within the next few business days in case you want to review that. Jesus, I don't know if you can quickly go back to the slides. We have just a question and answer slide with the link to our RapidMiner community, an email address that you can reach us at, and also our website and our Twitter handle. So feel free to reach us at any of those as well. I might just go ahead and ask these questions that were asked so we can reiterate them for everyone else on the line in case anyone else had the same question. So the first question was, what kind of license do you need to take advantage of the speed features? Lars, can you address that one?
Yes, then. So Jesus, to show one of the slides here with a bit of a table in it showing you the different editions of RapidMiner Studio then and what kind of support we have there. So as you can see in this table then, the free version uses one logical processor, so it does not really take advantage then of the multi-process execution. However, as you then get up into the small, we use 2 logical processors, then 4, and for the large, an unlimited number. So here you then take increasingly more advantage of the computational hardware you might have and the parallel execution. What's also key here for the large offering is this background process execution. So here's a feature too where you can then run those jobs in the background, and that could be very beneficial. So that's how that's structured.
Great, thanks. I have another question here. This person is asking, does RapidMiner support the JSON file format?
Yes, so...
yeah, you can go ahead and Jesus if you want to, yeah?
Yeah, so we do support it, and yeah, you can see the answer by Lars. There is a community text or comment on how we do it, but I mean in short, yes, we can read and take the JSON files.
Great, thanks. This person is asking, what is a logical processor, CPU, or core?
Okay, good. I can answer that. So this is how it usually is broken up then, right? You have a CPU which can have multiple cores. So often today a Windows machine or an Intel AMD machine that will have, let's say, one processor. It will have 2 cores in it. And then the systems can also do multi-threading. So each core will have 2 logical processors. So that's where that definition comes from. So logical processor is then the multi-threaded execution of a core within a CPU. So a very common CPU then would have 2 cores and hence 4 logical processors.
Great. Thanks, Lars. Another question here around Spark RM. Is it possible to create a process that receives data in real time from Hadoop?
In principle, Spark RM is using static data. So in fact, it is receiving data from the previous operator. So probably whatever you have used in terms of Hive or Impala or the like. There are some partners of ours that are working on extensions for, let's say, streaming on Hadoop, but it's not really there in the core of the product yet.
Okay, that's good to know. Another question here is parallel processing also improved when you're running it in the server?
Yes, so the idea is that this is in fact an improvement of or something that is running on the operator level. So all these operators that we have mentioned, when running on the server, will also use the number of cores that they can. I mean, yes, they will be running in parallel.
Okay, looks like we have another question here. How is performance of Spark RM compared to the Hadoop operator?
That's a good question. So in fact, the difference between other operators, the standard Hadoop operators, and Spark RM is not only related to performance. So in terms of performance, it could be more or less the same. But in fact, what we are doing with Spark RM is parallelizing the input data. So we are splitting the input, then running the algorithms or whatever is in the process on those pieces, and then we get the result, and we try to merge that into a single result. If you are, on the other hand, using, let's say, Spark MLlib's decision tree or logistic regression, the actual algorithm is being parallelized. So it's running in parallel. Not every algorithm can run in parallel. So in this case, we are adding more functionality even to some algorithms which cannot be run in parallel in any other way. So it still makes sense, depending on what you want to do with the algorithm, to use the old Hadoop operators. And as I say, in terms of performance, if you run, let's say, the same thing, one decision tree and our own RapidMiner decision tree, there shouldn't be much of a difference.
Okay, great. I have a follow-up question to a previous question that was asked about the JSON file format. They're asking about converting. Can you do it first without converting it to XML?
I think there is JSON to data operator that you could use, and I think that's the way we could do it. Yeah. Not sure if I have it exactly in my installed. Yeah, so this kind of operator is the one that you can use to read as a document a JSON text, and then it converts it to data. And once it is data, you can do as if it were just any RapidMiner example set. That's the way it works.
Okay, great. I think we're just about time here. So thanks everyone for staying in the line with us. And if we weren't able to address your question here on the line, we will make sure to follow up with you via email within the next few business days. So thanks again to Lars and Jesus, and thanks everyone for joining us for today's presentation. Have a great day.